Here we are in the last lesson of Unit 5. So we're bringing all of our identities in and all of our knowledge of trig functions, and we're going to solve trigonometric equations. Here we go. Find all the exact solutions for 8 sine of x equals 6 sine of x minus 1. So solving this, we should be seeing this or solving this as if we are solving 8x equals 6x minus 1. Okay? So a lot of these, the biggest window, the biggest door into doing this problem is just looking at it as stuff we've done before and stuff we were confident in. So if I'm solving this and it's similar to this problem, I'm just going to subtract 6 sine of x. So leaving us 2 sine of x equals 1, and we would divide by 2 here, leaving us with sine equals 1/2. The only difference is, much like if I had x squared, I would square root. I'll need to take now sine of x equals 1/2. Yes, I can do that mentally, but to write this down, I'm saying that x is going to be the arc sine, or the inverse sine, of 1/2. Unit circle, unit circle, unit circle. So if you want to go back real quick and look at some tips and some methods that I use for the unit circle and that I've shared with other students, I'll put a link here in the video for you to go back and watch that, because you will need to know your unit circle to do this. So sine is, I believe this is negative 1/2, yes. So sine is negative 1/2 at 7 pi over 6 and 11 pi over 6. So I do not have time to teach exactly why it's those two, because we should know this from the unit circle. You just know it. Sine is negative 1/2 at these two angles. So they are the solutions. So on to the next. Find all the exact solutions between 0 and 2 pi. Okay, so we have cosine squared and cosine x. What if we looked at this as 2x squared minus 5x equals negative 2. So what would the first thing you do for that be? Well, you would add 2, right? So let's add 2 to the left. So doing so would give us minus 5 cosine x plus 2. So doing that, you would say, oh, let's try factoring. So there are tons of ways that we could factor this, tons of methods that you've been taught. I like this little checkered board. Some call it a snowman, whatever you want to call it, whatever you use, that's factor. So you have 2, negative 5, and positive 2. So I'm thinking, oh, 2 and 1 to get negative 5. I'm going to do negative 2 and negative 1. That works for us. So our factors are 2. Now, typically we would write 2x, but here we have cosine, so 2 cosine of x minus 1, and then 1x, or just cosine of x, minus 2. Okay, so in solving this, using the zero product property, we could say, oh, if this times this equals 0, then either 2 cosine of x minus 1 equals 0, or cosine of x minus 2 equals 0. We just solve both of them. So in solving this, we get cosine of x equaling positive 1/2. Solving this, we will get cosine of x equals positive 2. This should throw up a red flag. Cosine nor sine will ever equal something greater than 1, because the range of sine and cosine is from negative 1 to 1, guys. Range, the output of sine and cosine will be within this region. So this is not possible. So, not possible. I would just leave that alone. I just disregard it now. So now thinking, oh, where is cosine equal to positive 1/2? Well, that's at the thirds. So positive 1/2, that's going to be pi over 3, and then 5 pi over 3 in the fourth quadrant. Again, unit circle, knowing that is very critical here, guys. And moving on. What's going on now? So find all exact solutions for 2 cosine squared plus cosine x. So using our little trick of just seeing this as, 2x squared plus x equals 0, how would you solve that? Well, I could think about factoring it, having a plus 0 there, but why not look at it as a common factor that I can pull out? So there's a cosine that they both have in common, so I can say cosine of x, and then 2 cosine of x plus, well, if I pulled this cosine out, I have a 1 here. Now, 0 product property. Cosine of x equals 0. 2 cosine of x plus 1 equals 0. So cosine is 0 at our 2's, at pi over 2 and 3 pi over 2. All right, and minus 1 divide by 2 gives us negative 1/2. So this is arc cosine of negative 1/2. That's at the 3's again. But negative 1/2, that's going to be 4 pi over 3 and 2 pi over 3. And I'm recognizing, and it's okay, because we haven't presented our final answer yet, we are in degrees. So our actual solutions, yes, it's pi over 2, 3 pi over 2, 4 pi over 3, and 2 pi over 3, but our actual solutions in degrees will be 90 degrees, 270 degrees, and then 4 pi over 3, that's 240 degrees, and 2 pi over 3 is 120 degrees. These are the solutions. And there we go. So, moving on. Find all exact solutions for, again, we are between 0 and 360. We have to recognize that. Well, you take a moment and think, what is different? What should strike you first is we have sines and cosines mixed together, and we have a double angle involved. So how? Let's wait a minute. Can't we get a minus sine squared from this? Let's see what happens. So sine squared of x. This is cosine squared minus sine squared. That's going to be nice for us. Okay. So yes, we have sine squares canceling, giving us cosine squared x minus cosine x. Common cosine, we can factor that out, giving us cosine x minus 1. All right, cosine of x equals 0. Cosine of x minus 1 equals 0. So we've done this one before, I believe. So this is going to be, again, 90 and 270. And then we have cosine of x equaling positive 1. So between 0 and 360, notice we can use both of these values. That's a good thing because cosine is 1 at 0 degrees and at 360 degrees. It's not common that we'll have both of those because they're technically the same angle, but according to our restriction, each of them are part of the solution. Let's see what's going on in our next example. So approximate. So we wanted to approximate the value for 3 sine of x minus 2 equals 7 sine of x minus 3. Now you might, when you think approximate, you might go and maybe y1, y2, and look for an intersection. That could work for you here, but I'm thinking that's going to make it really challenging because of just the nature of a sine and cosine graph with it oscillating. So let's solve this. So I'm seeing this problem, and hopefully you are as well. I'm seeing this as 3x minus 2 equals 7x minus 3. So I would move my 3x to the right. Okay, so that leaves us with negative 2 equals 4 sine of x. Now I add the 3, which gives us positive 1. So we're getting sine of x equals 1/4. This is not a fraction that we're used to. So the arc sine of 1/4 is not going to be one of our known angle measures. So on our calculator, making sure that we are in, yes, degree, yes we are, we take the inverse sine, so second sine of 1/4. And we get from this approximately, it's important to write approximately 14.5 degrees. Is it possible to have another angle? Is there another angle here? Because we're only getting one angle from that, and we've been seeing that we're getting 2, maybe 4 angles in these problems for solutions. So we're getting positive 14.5. So there is another angle. So where this other angle, how we think of it, is sine. Where else is sine positive? Because we're getting positive 14.5. Sine is positive in quadrants 1 and 2. So if I were to draw a picture for us here. So we have our 14.5 degree angle. We also have a 14.5 degree angle on this side, but that 14.5 is relative to this side of the x-axis. So what would it be reading it this way? Well, wouldn't it just be 180? Subtract 14.5? I think so. So in doing so, we find that x also is approximately 165.5 degrees. All right, so if we were in the third quadrant, so if sine was negative 14.5, that would mean that we have an angle in the fourth quadrant and in the third quadrant, and we would find the other in a similar fashion, using 180 or 360 there. Okay, so closing. That's a lie. We have 2 more examples for you here. So find the exact solutions for cotangent squared minus 3. Pause the video now and give this a shot. Cotangent squared minus 3 equals 0. How would we solve it? All right. So we added 3. We took the square root, knowing that we get positive, negative. I went from there and I split up my problem. So cotangent is the reciprocal of tangent. So the reciprocal of square root of 3 is square root of 3 over 3. So it's reciprocal because you get 1 over, yeah. So we can talk about that more if we need to. So the reciprocal here. So tangent is the square root of 3 over 3 at the 6's. Okay. If I had tangent of square root of 3, that's at the 3's. So tangent of 3 over 3 that's positive, so we're in quadrant 1 or 3. So our angles are pi over 6 and 7 pi over 6. And then tangent's negative in quadrants 2 and 4, which give us 5 pi over 6 and 11 pi over 6, and we have our solutions. Okay, moving on and ending with this problem. Find the exact solutions between 0 and 2 pi. For cosine squared x, tangent squared x equals 3. Now, you're probably wondering, we know identity. We have these identities. Cosine squared, isn't that 1 minus sine squared? tangent squared, isn't that secant squared minus 1? Sure, I could use my Pythagorean identities and maybe a half angle identity and just mess with this a little bit. But don't ever think that. What is tangent of x? Isn't tangent of x sine over cosine? So, tangent squared of x is the same as saying, oh, sine squared of x over cosine squared of x. Ah. Okay. So, 4 sine squared of x equals 3 dividing by 4. Square rooting. So the square root of 4 is just 2. All right. And, well, we can split this up if you want to. So arc sine of positive square root of 3 over 2. And then arc sine of negative square root of 3 over 2. So sine's positive in quadrants 1 and 2. We have pi over 3 and 2 pi over 3. And then sine's negative in quadrants 3 and 4. So we would have 4 pi over 3 and 5 pi over 3. And we have it. So we have now the solutions for this problem. So the biggest part of solving these trig equations, guys, is relating it back to something that we are accustomed to, used to solving. So do that when you go on and practice problems that you're given. Look at it as if it's an old algebra problem. And then just use identities where you need to when you get stuck. If you were to use an identity here other than the sine squared over cosine squared, it would have made the problem much more complex than it needed to be. So be smart about solving the problems. I wish you the best of luck. Continuing on, I wish you the best of luck on the test. And I'll see each of you guys in the next video.